Welcome to the Podkey summary of Meet the Evaluations Framework from WWDC 2026. Today's thread is really about a simple problem with messy consequences. AI features don't behave like ordinary software, so ordinary testing stops being enough pretty quickly. The big idea here is an evaluations framework that measures how often an AI system does the right thing, how often it drifts, and how developers can use that feedback to steadily tune prompts, judges, and datasets into something more reliable. And what makes this interesting is that it's not just about catching failures. It's about building a practical loop for improving AI behavior on purpose, instead of squinting at a few outputs and hoping for the best. Traditional unit tests are built around a pretty clean contract. Give the code an input, expect a specific output, and pass or fail from there. Generative AI blows right through that contract because the same prompt can produce different responses on different runs and still be broadly reasonable. So if you're testing an intelligent feature, consistency alone isn't enough. You need a way to ask something more practical. Like, how often does this feature stay within bounds? And how often does it produce something off, unsafe, or just unhelpful? That's the gap this evaluations framework is trying to fill. It shifts testing from a binary yes or no mindset into measured behavior over repeated samples. The architecture is flexible by design. There are protocols like evaluation, evaluator, metric, and model judge evaluator, so developers can define the inputs, define what gets measured, and define how results get rolled up. What's nice is that it plugs into Swift testing with the @test and @suite macros, which means these evaluations can live as first-class test targets right inside Xcode instead of floating around as some separate experimental tool. You import the framework, implement the evaluation protocol, and then you can generate reports with per-sample metrics, aggregate values, and even written rationales when a model judge is involved. That last part matters, because with AI features, the explanation for a score can be as useful as the score itself. One of the examples is almost charmingly plain, a metric called tag count. The job is straightforward. If a model is generating tags for book reviews, tag count checks whether the number of tags falls inside a target range, in this case 3 to 8. Each sample gets a pass or fail, and from there you can calculate an aggregate pass rate. In their book tagging service example, the target was 80% compliance. That's useful because it turns a fuzzy preference into a concrete threshold. You're no longer saying, this seems okay. You're saying, we want this behavior at least 80% of the time. They also extend the metric to record the exact number of tags, called tag total, so you can inspect the distribution instead of just looking at pass rates. And that's where things get more revealing, because a passing system can still have odd habits. The speakers describe prompt refinement as hill climbing, which is a good phrase for it. You make a change, run the evaluation again, and see whether you move closer to the behavior you want. In the tagging example, they added a count range directly into the instructions through the @guide macro, specifying 3 to 8 tags. That helped steer the model, but it also produced a new pattern. The service started consistently returning 8 tags, which is technically within range, but also a reminder that models love to satisfy the letter of the request in very specific ways. Once you can see the output distribution, that kind of behavior stops being invisible. And once it stops being invisible, you can start tuning for it. That's really the heart of evaluation-driven development. The loop is fast enough that prompt writing becomes less of an art project and more of a measurable iteration process. Some qualities just don't map neatly to code. Relevance, usefulness, whether the output actually helps a person reading it. Those are harder to capture with a rigid rule. That's where the model judge comes in. It's a secondary language model that scores outputs on a scale, like 1 to 4, based on a scoring guide, instructions, and context. The framework treats that judge like any other evaluator, so you can mix qualitative scoring with hard metrics in the same evaluation run. And the rationales matter a lot here. If the judge scores something in a way the developer doesn't expect, that mismatch usually points to ambiguity somewhere. Maybe the scoring guide is too broad. Maybe relevance and usefulness are getting lumped together when they should be separate dimensions. Maybe the judge doesn't have enough app context to understand what good looks like. So the disagreement is actually useful. It tells you the evaluation itself needs refinement, not just the model output. There's also a very practical dataset problem here. Handwriting hundreds or thousands of examples is expensive and kind of soul-draining if we're being honest. So the framework includes a sample generator that can use a model to synthesize more model samples and expand the evaluation set. That lets developers start small and then broaden the dataset to uncover edge cases and test whether their metrics still hold up across more varied inputs. In the demo, they take the book tagging dataset from just 2 reviews and expand it out across the whole library. That wider set included longer reviews, different styles, and more variety. And it confirmed that the model's 8-tag habit wasn't a fluke from a tiny sample. It persisted. That's exactly the kind of thing synthetic expansion is good at. It helps separate a one-off quirk from a real behavioral pattern. Put all of this together, and you get a pretty clear workflow. Define expectations, run the evaluation, inspect the quantitative and qualitative results, refine the prompt or the judge, and run it again. Each iteration is guided by metric feedback instead of intuition alone, and each change can be tracked in test notes so the process stays reproducible. That's why they call it evaluation-driven development. The evaluation isn't a final gate at the end. It becomes the thing steering the work all the way through. For AI features, that's a meaningful shift, because reliability is less about proving perfection and more about steadily tightening behavior with evidence. A few guidelines stood out as especially useful. Start with a small focused dataset, something like 20 to 30 samples, so you can prototype the metrics before you scale anything up. Use heuristic, code-measurable metrics for traits you can count or check directly, and reach for Model Judge Evaluator when the quality you care about can only really be described in words. If Model Judge scores all start looking suspiciously uniform, split the scoring dimensions, so the judge has less room to blur everything together. And if the rationales show the judge misunderstanding the task, add more explicit app context to the prompt rather than pretending the confusion isn't there. None of this guarantees perfect AI behavior, but it does give teams a disciplined way to surface hidden issues early and improve trustworthiness much faster. The broader takeaway is pretty calm and pretty useful. If software is probabilistic, the testing has to become probabilistic too. And once you have a loop for measuring behavior, not just inspecting a couple lucky outputs, AI development starts to look a lot less like guesswork. Which is good, because it seemed fine on my laptop was never going to be a great strategy for language models. This episode was generated by Podkey. Create your own at podkey.fm.